Hi! Welcome to this first real reveal of Continuum, a piece of software that I personally tried and that left me amazed. Finally, a bit of fresh air in the world of astrophotography. Let's start with the UI. I find it really convenient that all the tabs can be detached and placed wherever we want, especially the node section, which, since I have two monitors, I move over there. Now let's move on to the editing, which is the most professional and fastest thing I've ever seen in my entire career. Up here, we can control all the live scopes and enable them: histogram, waveform, vector scope, FWHM, and SNR. I'll enable them all to show them. Let's start right away with a stretch of this file made up of 6 hours of exposure in LRGB. All we need to do is drag and drop the relevant node into the workflow and connect the output to the input, and then work on it. I'll limit myself to increasing the midtones before the stretch, because I want to do a color balance. Now let's take the color calibration node and connect it to the first stretch. I'll leave the automatic color calibration because the result satisfies me. The great thing about Continuum, besides its simplicity, is that all the editing is never final. At any moment we can select an old node and modify it, seeing the change render and propagate all the way to the last node, unlike other software where every modification is final and irreversible. Before doing star removal with Axiom, let's apply a slightly more aggressive stretch, because Axiom works well and is optimized for images with at least a bit of stretch. So, let's bring the starless Axiom node into the workflow and click Start Process. The starless Axiom node is the only irreversible one. Once it's applied, the previous nodes can no longer be modified unless the starless node is deleted. This will be indicated by the previous nodes turning red. Now we wait for the process to finish. When the process finishes, it will create another node called Only Star, but we'll set that aside and use it at the end. For now, let's focus on the editing. I'd say that now that there are no more stars creating incorrect contrast, we can proceed with an aggressive stretch. So let's go ahead and stretch the curve. Now I'm going to remove a bit of green and balance the red using color calibration. I think now, I'll do a bit of generic editing. The power of Continuum also lies in having classic editing tools in addition to scientific ones, so you always have full control. We can also find masks, which we'll look at later. With shadows, exposure, and contrast, I'm trying to give the image a sense of three-dimensionality. I'd say that now we can do an trous wavelet, which is a mathematical image processing technique used to separate and control details at different scales without shifting pixels. It's an extremely powerful tool for bringing out nebulae, galactic structures, and fine details without destroying the signal. Let's adjust the individual scales, but this is just an introduction. When it's released, I'll make detailed tutorials for each node, as agreed with SciCon. Let's adjust the colors a bit with photometric color, which, even though it's aesthetically similar, uses a different color management approach. In this case, the control is more micrometric and precise. Now, let's apply local normalization, which in this case Since the image is fairly well balanced, we'll have a minimal effect. Local normalization does the following. It calculates a low-frequency model, blurred, medians, surfaces, uses it to even out local brightness or contrast, and leaves high-frequency details intact. At this point, we can apply HDR local contrast to give fine detail and micrometric contrast. Scicon's algorithm uses a frequency divider to separate finer details and differences between shadows and highlights. You can see the result for yourselves. Now let's do a bit of final editing on the image to make it more saturated and brighter. The editing node in Continuum is not a classic editor like the ones you can find in Lightroom or Photoshop, but it has solid scientific foundations for astrophotography behind it. You'll notice substantial differences in use. Now, even though it's not necessary for this edit, I'll show you the power of masks with an example. We place the node we're interested in, and in between, we add a mask. In this case, I'll use a dark mask. We connect it to the output and edit the mask. Keeping in mind that white represents the part that will be edited by the next node. When we're done, we connect the mask to the white mask input and connect the previous node to the next one. We then choose whether we want the mask to affect, meaning it edits the part of the image covered by the mask, or exclude, which instead excludes the mask and edits everything else. From here, we can do whatever we want. In this case, I'll slightly desaturate the sky background. Now that we've finished the editing, very quickly for this tutorial, we can connect the only star node, wait for it to render, and we'll see the stars being reapplied to the image. The stars, of course, can also be edited. In this tutorial, we've seen only 10% of Continuum's power, and the core team still hasn't delivered many features to me. But if these are the premises, I can shout out loud that this is a true revolution, both in terms of workflow speed and non-destructive editing, since all nodes are editable and retroactive. The cool thing is that the node-based workflow can be exported, saved, and reused for other images. But for now, I can't provide any further information. We'll definitely meet again in the next tutorial. This video will definitely be published on Scicon's YouTube channel, so please leave a comment and let me know what you think. I really care about it. I wish you clear skies. See you next time.